All right, let's do it. Let's unpack this, starting at the perimeter. Let's hit layer 1.
The gatekeeper.
Our journey begins right where the request enters the cluster network boundary.
Yeah.
So layer 1, you called it the gatekeeper. And in Kubernetes, that role is played by the Ingress controller.
Exactly. Think of the Ingress controller as the HTTP receptionist for your entire cluster. It is fundamentally a layer 7, an application layer traffic manager.
Okay, layer 7. That's a key distinction. It's not just routing packets based on IP addresses.
No, not at all. It's much smarter than that. It handles things like hostname routing, sending api.coolapp.com to one service and website.coolapp.com to another. It does path matching. And often it handles cryptographic functions like TLS.
So if the receptionist doesn't approve my ID, meaning the host header in my HTTP request doesn't match a rule, my request is just terminated.
It's terminated right there. It never even sees the internal services. It's a hard stop.
You've isolated two crucial components here that I think people often get confused about.
Yeah.
The rules themselves versus the thing that enforces the rules.
That's right. And it's a critical separation. First, you have the rules. That's the declarative ingress resource. It's the YAML manifest you write that says, if someone asks for api.coolapp.com your malwares, please send them to the user service.
That's my intent.
That's your intent. Second, you have the enforcement mechanism, the actual running Ingress controller pods. These are typically built on really high-performance proxies. You've heard of them, NGINX, a proxy, or Envoy.
And that controller is just sitting there in a loop, watching for new Ingress resources to appear.
It's a classic Kubernetes control loop. It continuously reads those declarative rules and programs the proxy configuration in real time. A new Ingress object appears, the controller sees it, and it reconfigures NGINX on the fly.
And the choice of that controller, that matters a lot, doesn't it? Because different vendors, like NGINX versus Envoy, they handle that reloading very differently.
Oh, it matters immensely. This can introduce subtle latency when you're scaling up or changing services. For example, some older NGINX Ingress controllers might require a full configuration reload to pick up a new rule.
Which could mean dropping a few connections, right?
It could, even if it's just for a fraction of a second. Whereas something like Envoy, which is used in a lot of modern service meshes or controllers like Contour, it uses this highly dynamic API called XDS to update its routes instantly without dropping a single connection.
That's a subtle, but wow, a massive performance difference at scale.
It really is.
Yeah.
Now, how does the outside world even discover this receptionist? This is where your Kubernetes cluster has to touch the cloud provider infrastructure.
Right, because the Ingress controller is just a pod. It has some internal cluster IP. My laptop can't reach that directly.
Correct. So most commonly, the Ingress controller pods are fronted by a Kubernetes service of type load balancer.
And that's a magic word in Kubernetes.
It is. It's a special keyword that instructs your cloud provider, AWS, Azure, GCP, whoever, to go and provision an external, typically layer 4, network load balancer and point all of its traffic toward your controller pods.
So the cloud gives me a public IP address, and that IP points to my Ingress pods.
That's the most common path. Alternatively, say in a bare metal setup or a really high-density private cloud, you might deploy the controller as a daemon set.
So one pod on every single node.
On every single node, ensuring it's running locally, and then you'd point some centralized external hardware or software load balancer to the specific node port used by that daemon set. The common thread is there must be a public physical IP address managed externally that gets traffic to the Ingress controller.
Okay, and since we're at layer 7, let's talk security. This is the natural place for things like TLS termination and web application firewalls, right?
Absolutely. TLS, or Transport Layer Security, is critical here. The controller has to terminate TLS.
Meaning it decrypts the request.
It has to decrypt it specifically so it can inspect the HTTP headers, the host name, which it gets from a TLS feature called SNI, and the path. This requires the controller to hold the private keys and certificates.
And those are stored in Kubernetes secrets.
Stored in Kubernetes secrets, which the controller pod has permission to read.
And what happens if that process fails? If the certificate is wrong?
You get an immediate high visibility failure. If the certificate is expired, or if the host name you requested doesn't match the certificate the controller provides, your browser or your curl client throws an immediate fatal TLS handshake error.
So you don't even get to the point of sending the actual HTTP request.
Never. The conversation ends before it begins. It's a very clear signal.
You also mentioned way integration. How does a web application firewall fit into this layer 1 picture?
So Away also operates at layer 7. It inspects the content of the request, but it does this after TLS termination. It's looking for patterns that indicate attacks, things like SQL injection, cross-site scripting, the usual suspects.
So it's another layer of inspection.
It's an additional validation layer. When you integrate it with the Ingress controller, which is usually done as an add-on or maybe a sidecar proxy, the WAFAX is a security check before the request is routed internally. It's your first and strongest line of defense.
Okay, so if the receptionist sees suspicious behavior, the request is blocked right there. It never touches the actual application.
Exactly, long before it gets anywhere near your application code.
Let's talk about the common failure modes here and how to diagnose them effectively. This is where people get stuck.
Right. The failures here are usually pretty binary. It's either a complete connection refusal because of a TLS issue, or it's a routing failure. And the classic routing failure is the 404 not found.
Okay, a 404. If I get a 404, how do I know if the Ingress controller never even received my packet, or if it received it but just couldn't match the rule? That's a really key distinction.
That is the key distinction. If the Ingress controller never receives the packet, you're not going to get a 404. You're going to get a connection timeout or maybe a connection reset. That points to a problem at a lower layer, maybe your cloud load balancer or the network fabric.
But a 404 is different.
A 404 is a layer 7 response. It's a polite no. It means the controller successfully accepted the TCP connection, it successfully terminated TLS, it read your HTTP request headers, the host, the path, the method. It looked at its internal routing table that it built from all the Ingress resources.
And it found nothing.
And it found no matching backend service.
So in a weird way, receiving a 404 means layer 1 is actually working as intended, but my configuration is wrong.
Precisely. The receptionist is doing their job perfectly. You just ask for an office that doesn't exist. The evidence is clear. Check your declarative rules. Run kubectl, get ingress YAML. If the host or the path is wrong in that file, that's your fix.
Now, to eliminate variables and diagnose layer 1 specifically, there's this synthetic test you mentioned, which is in our sources. This is so valuable.
It is, because DNS can really obscure the actual problem. Your DNS could be pointing to the wrong IP, for example. You need a way to bypass the DNS lookup while still tricking the Ingress controller into thinking the request came from the correct domain.
The command for that is?
The command is curl-vk first flag resolve-api.cuLab.com.443.lbip https.api.cuLab.com users.
Okay, let's break that down. The resolve flag is the magic here.
It's pure magic. It tells curl, hey, for this one command only, anytime you need to connect to api.cuLab.com on port 443, don't use DNS. Go directly to this IP address, which is the public IP of your cloud load balancer.
Well, it forces the connection directly to the load balancer, but, and this is the important part, it still sends the correct api.cuLab.com host name in the TLS SNI header and the HTTP host header.
Exactly. So the controller thinks it's a legitimate request for that domain. If this command fails with a TLS error or a 404, with 100% certainty that the problem is specifically your layer 1 configuration, your certificates, your secrets, your routing rules, and it has nothing to do with your public DNS setup.
Mastering that single command is a huge step in structured debugging.
It really is. It isolates layer 1 from the entire dependency chain that comes before it.
Okay, so the request successfully navigated the gatekeeper. The Ingress controller read the rules. It knows exactly where to send the traffic, let's say to the data processing service. This transition moves us from the edge inside the cluster to layer 2, the stable directory.